for this size for
Hello
the number
everyone,
of
this
elements
is
in
day
this.
7 of my challenge, and in this
For
video I'm
every
going
I
to
have
explain
done
all
months
about
of I,
hashing,
this
like
this
all
in
the
C++.
concepts involved in hashing, and then I will be solving some of the basic 6 to 7
That's
problems
the
of hashing. But
that's
firstly,
the
getting into
mistake.
that, what is hashing, what hashing does, firstly we should know that why
Done like
hashing
this.
exists, what is the purpose of hashing, that why it came into existence. So firstly, let's talk about a simple example that let's say we are having this array and we have to find that how many times this 7 appears in this array. So in that case, what can be the simplest approach we can follow? That yes, I want 7 to be count. I want the count of 7, that how many times it appears in this array. So I can just traverse in this whole array and I can get the count that firstly 7 whenever I will found a 7, I will just increment the counter, and at the end I will return the counter that yes, 7 appears 3 times in this array. So I will just keep a that this is the key. I have to find like how many times it appears, and I will then just traverse in this array, traverse the array. So just traverse in this array, and then at the end keep the counter for 7, how many times it appears, and then just return the count that 3 and 7 appears 3 times. This is the simplest possible approach we can follow. Now just imagine that instead of 7, I want the count of all the elements, like whatever the elements are present in this array, I want the count for all, how many times they appear. So in that case, I will have to use some of the a kind of array where I can make the where I can just keep the occurrences or keep the frequencies of every element, that these number of times they are present in the array, and then at the end whenever I want the result, I can just go at that array and will get that frequency. So just like this input array, the same I have taken, and now I will be maintaining because I want the frequency for all the elements, so I will be maintaining a frequency array in order to get the frequencies of all the elements. So I have taken this frequency array will be of 9 size. Why? Because the array size, this maximum value which is present in this input array, that is 8. So maximum value is 8, so we will have to take the maximum value plus 1 size, because this is 8. So whatever the indexes are there in this frequency array, those will be representing the elements, and inside that whatever the values are, they will be representing the frequencies of those elements. So if I have to get to the index till 0 to 8, I will have to take the 9 size array, so that it can go from 0 to 8, as 0 based indexing is there. So I will just take the frequency here of array of 9 size, and every time I will get the element and increment its frequency count in this array. So for 7 it becomes 3 at the end, for all the elements it becomes 1, because they are available one time in the input array. This is how we can do if we have to get the frequencies of all the numbers. Now the thing is that there the smaller values are there, like till 8, or any of the example can be there, like till 10, or till, let's say, for even for 100, or for for the maximum value, which can be the maximum value can be 10 to the power 6. So if we are having any data in which we have to calculate, in which we have to find the frequencies of the elements, so in that the maximum value can go up to the a particular value which is closer to 10 to the power 6 or something, so so that whatever the maximum frequency array can be made, or can be declared, that can go till 10 to the power 6, that is maximum. But after that, if the values are something like that, the data is very large, like 10 to the power 7 or 10 to the power 8, means beyond 10 to the power 6, 10 to the power 5 or 10 to the power 6, then in that case the array size, this frequency array, will have to be declared for that maximum value, but it can't be declared because that goes way beyond, it is maximum limit of the declaring the array size. So this is the case. In this, we have in these two examples, we have just seen that if we have to count the frequencies, the value should be uh, having in a particular range, or the smaller enough, so that we can declare the array size. But beyond that, we can't declare the array size. So that's what the problem coming in this case, when we are using the array in order to get the frequencies. So that is only available if the values are smaller enough, the range is smaller. And one other case is also there, like there can also be the negative value, so in that case we can't use the array hashing form. So now what are the limitations of array hashing? I have simply what I have just explained, that if the values are large enough, like this is the large value. Now obviously if this is the large value in this array, then we will have to declare the array size of max of this maximum value plus 1, then but it can't be done. We can see that it is a very uh, greater value as compared to 10 to the power 6. So we can't make the frequency array of this size. So that's where the array hashing fails. And now obviously if the array hashing fails, then we need some of the some technique or a way, and so that we can do this same process in the very efficient manner. So this is a way that we can map any of the number to the smaller value or the manageable range. What the problem is coming? The problem is coming for the range itself, for the larger values itself. So if we can map these numbers to the smaller values or the manageable range, we can get through it. So how we can store and find any of the numbers fast, even if it is huge? Like this was the example we have seen, that this is a very huge value. How we can do this? So here the same value which I have taken, how we can do that? Because in array we can't create the array size of that huge range or huge value. So that we can do with the help of the hashing in which we can use the maps. Okay, so how do we store and find any of the number fast, even if it is used? So by using a function, which the in the hashing technique, which will be using the function, and that will be known as the hash function. We will see what a hash function is, what it does, and then storing the mechanism. A storage mechanism will be there, that will be the hash table. So whatever the values will be coming, we will be storing inside the hash table. As we are storing inside the array, we will be storing inside the hash table. Now key index mapping will be there, like a value will be there and it will be mapped with some of the index, like based on what the problem we are solving, on that basis. And hashing turns the bigger values into the smaller index, that we will just see in a while what how it happens, how the bigger values convert into the smaller indexes. Just the same example I have taken in the array case, the value we are having this. Now this is the hash function I am talking about. This is the hash function. It depends on what mod operation we have to perform, on the basis of what number of buckets we have to use. Buckets are like in the hash table, there are the sections we call as them as the buckets, in which the values are stored after the hash function, the hash value is found for them. So let's see if this value is there and we have to store it inside the this hash table. So how we can do that? We will simply use a hash function. Hash function looks something like this, that whatever the value we are having, take that value and perform the mod operation with the number of buckets. So if the number of buckets are 10, then we will be performing that with modulus of 10. Okay, so what we have to firstly get that we that comes on the basis of what number of buckets are there. Okay, so hash value will be what this is the value, and which when the mod operation is performed, it will give the value. Now the whatever the value is coming, this is the value of the bucket index. So if this is the bucket that, and if its index is 7, then this particular value will be going inside this bucket. This is the meaning of this. So this particular value will be mapped it into the index 7. Now let's move ahead. Now using the arrays as hash tables. So this is the hashing which we do in the form of, like, whatever the values comes, they comes inside the hash table. We will move ahead when we talk further about this, like hash function, what is hash function, how the values are stored, how the key index maps, that we will see. Now using the arrays as hash tables, firstly, now this is a frequency array hashing. So array hashing, in which we just explained, I have just explained earlier, that whatever the values which comes, which are having the smaller values, that can be done using the arrays. Like the arrays can be used as the hash table, so that we can keep the frequencies of those. And it is used only when the values are small enough and within the known range. For example, this is the example we are having, and now we have to keep the frequencies of these elements. Okay, so now what we can do is, we will just keep a frequency array, or I can just write in this way, that we have to keep the frequency array. Now what will be the size of this frequency array? Because the maximum value is going till 4, so I will have to get the indexes for till 0 to 4. So for that, the frequency array will be declared of size 5. Now in this case, firstly I will be just initializing all those values with 0, and now I am having this frequency array. Now I will just traverse through this entire array. Okay, for just loop through this. So loop in the array, and when we are looping, what we will say, that yes, whatever the value is coming, we will just go in the frequency array for that particular value and increment its frequency count. So just go inside the frequency array, and for that particular value, this loop is running for this. So for nums of I, this is the nums array, or this is the array, arr of nums, or arr of I. So just go at that value, as this is the 0th index, so arr of 0, that will be 1. So it means this is the value 1. So just go at arr of 0, that is 1. So frequency of 1, it will be incremented. For 1th index, whatever the 1 index is there in frequency, the frequency count for 1 will be incremented to 1, that yes, 1 present. uh, as of now one time. Then for 3 it will same will happen, for 2 same will happen, for 1. At the end, whatever the number of elements are present in this array, those frequencies will be uh, placed, those frequencies will be counted inside the frequency array. And at the end, if we want that, yes, I want this, the number of elements whatever the times they are presenting, or the number of occurrences, we can just print those using the frequency array. Just go inside the frequency array and just tell that, yes, whatever the elements are having whose frequency is greater than 0, just print those. So we can do that. Now this is the arrays as hash tables I have also explained earlier, and now it is more clear. Just use for the smaller values within the known range. Now second is the character hashing. Now in character hashing, what happens is there are the like different categories. Like if the characters are from small a to small z, small z, that is the 26 characters, the lowercase characters. From capital A to capital Z, that are again 26 characters uppercase. Or can be from 0 to 9, like the total 10 characters are there in the form. And one another is that if we have to take all the possibilities of the characters, so that can go from 0 to 255. That is, the ASCII codes are there. These are the ASCII codes for all those characters. So those, like 256 characters total. So 256 characters. So this can be the case. So there can be the different cases based on what problem we are solving. Like if we are given in a string with the characters from small a to small z, only the lower case or uppercase, then in that case we can keep the frequency array for 26 size in order to keep their frequencies. But if we are having the characters in the string, they are mixed, like the different symbol characters are there, like dollar character, hash character, numbers are also there, uppercase, lowercase letters are also there. So in that case, we can just in order to be at the safer side, we can just use this ASCII, sorry, this size of 256 characters in the frequency array. So in this frequency array, now if we are dealing with these with the string which is having only these characters from the small characters, small letter characters, then in that case, how we can map these? Like there can be the like a based offsets can be there. Like if we are maintaining a frequency array, and in that we have to maintain the a based offsets, like a will be mapped to 0, b will be mapped to 1. So in that case, we use this particular a kind of formula, that whatever the character we are getting from the string, just take that character and uh, use this formula character minus a, so that it can be mapped with the indexes. Just like if I'm having a array of a particular I'm having an array, I have to map it. So I can just take every character from string and just do this, perform this operation, character minus a, so that if a is there, a minus a, that will be 0. So it will be mapped with 0, and its counter will be implemented at that 0th index. If b is coming, b minus a, that is a kind of ASCII code. Whatever the values, they get subtracted and then converted into the character, so that for that character, then counter is implemented. So likewise it can be done. You will just seen a problem when you will be solving the problems, kind of problem for character, counting the occurrences of the character. So this is the case. We have just seen the these sizes for the frequencies that is can be taken. If lower size, then we can take, or the a lower or upper size, we can take 26 and 26 separately. If both are there, then we can take the size of 52. Otherwise, we can take, in order to be at the safer side, we can take the 2, so that all the cases can be involved in that. Now, after these, after seeing the the array hashing, after seeing the character hashing, now the array hashing is only used whenever the smaller values are there or the smaller ranges are there. And in the case of characters, we have already seen that, because in that case, total 256 characters can only be there. That is the possible case. So there is no need of using such like the another way or another technique. So in that case, they are the fixed. So we can use the frequency array or frequency hashing. We can. Now after this, whatever the bigger values are there, or for the larger values, we have to use the unordered map. That is the hash table, which uses the hash table. So unordered map, firstly, what is unordered map? Now whenever the array hashing fails, obviously it is failing on the range when the range gets too bigger or the values gets too bigger. So in that case, the array hashing fails. In that case, we can't take the arrays of that particular sizes, larger sizes. So here comes the important way or the technique, we can say, in order by using the unordered map we can do this thing. Unordered map is what? Unordered map is a, as we have already seen in the STL video, which I have explained, in which I have explained the different containers. In that, unordered map was also one of the container which is having the key value pairs in the form of, it stores the key value form of pairs, and in that every key is unique, but that is unordered, not sorted. Okay, and another one is the like map itself, which is having the sorted order, that we will just see that what is the difference between. So this is the unordered map here, which stores the data in the hash table, and inside that hash table, it stores in the form of key value pairs, where it depends on what problem we are solving, the keys and values which they differ. Like whatever the characters are there, we have to count the frequencies, or we have to get the indexes of those particular elements. So it depends. So with the help of unordered map, we can solve all those problems. Like for the any of the bigger size, any of the value, we can solve this because it stores any of the value. Simple. It stores any of the value, like it can be of intent, it can be of long int, it can be of the string int, like that. And it maps to the buckets internally. Okay, and it also gives the constant lookup on average. So whatever the values we are storing, whatever the data we are storing, if we have to access it instant at the instant access, so it can give that instant access. So that is in the constant time. And no matter how the large is the key is, that's what the problem it is solving, because the if any of the larger values there, bigger value there, it doesn't matter. It just uses the hash function and puts it inside the bucket at a particular index, whatever it comes. So this is the unordered map. Now this is used whenever the values are large enough. Now why can't we use an array as a hash table for every problem? That we already discussed. Just to have a recap, that array hashing only works when the range of the values is small, and if the values are large, like 10 to the power 9 or negative or strings, just I have mentioned, we cannot just create an array of that huge size. It would exceed the memory limits. And normally, yes, that I have already told that if the normally if the array size is like 10 to the power 6, it is always safe. But it is going, if the 10 to the power 7 or just beyond 10 to the power 6, it is not safer, it is not at the safer side. It is, the memory limit will be, if the high, then only it can be done, otherwise the array can't be declared of that of that huge size. So array hashing is only for the small integer ranges, just like from 0 to 10 to the power 5 or 10 to the power 6. And character hashing, that is no problem in that case, because size can be 26 or maximum 256, just to have a safer end. Now, the topic starts, that what is hashing actually. So as we have just discussed that why we need hashing and why it came into existence, that was very important to know. Now, what is hashing? Let's discuss about this. So hashing is simple, that whatever the input values are we are given with, if the input sizes, the if input values are large enough, so that we can we can take those large values and then convert them into the smaller indexes quickly, so that we can store it in the particular bucket indexes. This is what hashing all about. Hashing is simply converting the large input values into the small indexes quickly. It allows the constant average lookup, obviously, because whenever the values are coming, we have to whenever the values are we want to get, we want the instant access. So that is the very important feature of this constant average insertion. If we have to insert any value, that can be done in constant time. Handles the huge values, that is the bigger advantage, and the only use of this. Then no sorting is there. Okay, and now here no searching linearly. Simple, because it is taking the for the searching, no searching is linear. Now the same example, this is the larger value. Now I have to store this inside the hash table, where the bucket index will be 7, because when the mod operation will be performed with 10, it will be stored at the seventh bucket index using the mod operation. Now it uses the hash function. Let's talk about the hash function, what it is. So whenever the value comes, it uses the hash function in order to get the index, that where I have to store that. The hash function h of x, it simply maps that particular key. If the x is a key, then it will map that x to an integer in a fixed range, right? Like just think that if b number of buckets are there, so bucket indexes will be from 0 to b minus 1. These are called the buckets, and the hash table stores the elements in these buckets, resolving the collisions using the chaining. So chaining is the concept which we will also talk in the collision part, but just a brief about this, that whenever the all the values comes and get into the same bucket, then at that time the hash table, it internally it uses the linked list in order to store these when more number of values come inside the same bucket. Now Pre-computation is simple, that whatever the values we are having, if we have to count the frequencies of those, we will just keep the pre-computation of those. These are the number of frequency or the occurrences of these elements are there, and then we can just access those values instantly, just having a constant lookup. Okay, so just compute something once and use it many times, just like that. That is the pre-computation. So frequency array, that is a pre-computed count. Obviously, if we are keeping the frequency of the elements inside the arrays, that is a pre-computed count. And later on, whenever we want the frequency of any element, we can just go inside that frequency array, and we will get its occurrence. That's in the time, constant lookup. Now, how to declare a hash? So this is a hash array. If we are using a array hash for the smaller values, if smaller ranges are there, then in that case we can just create a frequency array, or we can say a hash array. So it can go maximum up till this value, like 10 to the power 6 if the maximum value is there. So it can go till here, and just declare, just get those values as 0, initialize them, and that's for the values in the range from 0 to 10 to the power 6. And if we are using the character hash frequency in character hash, then in that case the size can be maximum for 256. That's enough, and we do not need for the map in that case. So this int frequency, we will just get that to give this to 26. In case if we are having the lowercase letters, so just we can get it, and in order to increment its frequency count, we will just use the a based like offsets, just to map those characters with the indexes, like 0 to a, then 1 to b, like that. And then unordered map, that is the general hashing technique, which is used whenever the values are going very large enough in order to solve the problem. So unordered map, that is, it is declared in this way, unordered map, and then we give the parameters here, like whatever the data types are there for the key value index and key value pairs, and just give the name of this here. And it can be, like I have already mentioned, that it can be of a string int, it can be of long boot, like that. This is all about the declaring a hash. Now let's talk about the difference between that. What is this? The difference between the unordered map and the ordered map. So map is something which is implemented using the red black tree, and it is just the same thing which I have already discussed in the previous video, or in the STL video. That is, the map is something which stores the values inside, like in the key value pair only, but all the keys are, they are unique, and as well as they are sorted. But in the unordered map, they are not sorted. Okay, there is no order, so if the order doesn't matter, we can use the unordered map. So this map is implemented using the red black tree. Unordered map is implemented using the hash table. Order in the map is sorted, and in the unordered map it is not sorted. Time for the map, like the operations which are done, that is big O of log n, and in this unordered map, that is for the lookup and for the for the insertion, like such things, it is constant. And map is best for the sorted queries, and unordered map is best for the fast lookup. That's the Now, why unordered map needs a hash function and why the map does not need a hash function? That's very simple, because the unordered map uses the unordered map is implemented using the hash table, and this map is implemented using the red black tree. So that's very simple, that if the unordered map is implemented using the hash table, then it's obvious that in order to store the values, it will be having the buckets with different indexes, and in order to place the values at the perfect bucket index, we will have to use a hash function. But if we are not using the hash function, then there is no way in order to put our values inside the bucket indexes. So that's why we use the hash function, which looks something like this. Whatever the bucket index will be, it will be coming after performing the hash key. Whatever the key is there, just take that key and perform the modulus operation with the bucket count. So whatever the number of buckets will be there, you will be performing the modulus operation with that bucket count. So that's why we have to use the hash function. But in the uh, this map, in that case, because it is implemented using the red black tree, so in that case it has to only keep the values in the sorted form. So it has to just make the comparison, that if the key is lesser than the key 2, so you can just go at the left, or if the key 1 is greater than key 2, then just go at the right, because in the map it is all about the order, that is the sorted order. So just it has to keep the sorted order. So it will just uh, it need not any kind of hash function. So in order to just make the comparisons, that's the simple thing here. Now BSTs, obviously it is implemented using BSTs, so they depend on the ordering, not on the hashing. That's why the hash function. The simple note is that the unordered map uses a hash table and needs a hash function. in order to convert the keys into the bucket indices. And map uses the balanced binary search tree, uh, or the red black tree. So it only requires the key comparisons because it has to make the order, the sorted order. So it does not need a hash function. That's all. Now let's get into the collision, that how the what is collision, how the collisions happen, and how we can handle those. So collision is a simple that which happens whenever the two different keys, when they come and they just go at the same hash index. Okay, if the two values are coming, or if the we can say if two keys are coming, and when the hash function is applied on those, and whatever the bucket index came, if the bucket index is same for both the keys, then in that case those both the keys will be going at the same uh, in the same bucket. That's in the kind of linked list which is done, the linked list which is used internally inside the hash table inside the buckets. So this is the collision. If the x and y are the keys and hash function is performed on those, and those both indexes are equal, obviously the keys are different. So if both indexes are equal, then in that case the collision occurs. And here the chaining is used. Chaining is the method which is used in this unordered map. Okay. So that's now chaining is the method which is used in order to avoid this collision. So this is the simple example I have taken, this hash table with 5 buckets. Okay, hash table is there with 5 buckets. Now let's take this hash function as, yes, hash function will be this, like modulus operation with 5, because 5 buckets are there. And now these are the values which I have to insert. And now if I perform the modulus operation, then those all of the these keys will be going at the same bucket index, because those all the bucket indexes are coming as equal to 2. So at the second index, all those will be going at the same index, like 12 will be coming, 22, 42, and then 7. So this is called the as chaining, because they are internally using the linked list, this hash table. So this is called chaining, and this is the method which is used in order to handle the collision. So collision handling method is chaining. Each bucket stores the linked list or the vector, we can say, of the elements. So if we see in this, the lookup will be like what the hash key, and just get the hash key, and then just go to that bucket, and inside that bucket search inside the chain. That is going to be the lookup, just to have those values. And in the average case, if we see, then it is going to be constant, because if every value is a different bucket, then we can just get those values in the constant time. But if like just in this case, if we can just in this case that we can see that whatever the values are there, they are going at the same bucket, in the same bucket. So now if we have to perform the lookup, then we will have to the worst case, in the worst case, that will be big O of n, because all the keys are going in the same bucket. So in order to get the excess of the any values, we will have to see for number of values or number of elements, whatever number of values are going inside the same. So that's what the lookup is going to. Another example you can take of the strings, like if any of the like these are the strings, then you can just take the length of the string and perform the modulus operation with number of buckets. And then just in this case, that some of the strings are these two are going at third index, strings are going at fourth index, one is going at second index. So that's how the number of these every string is going in a particular bucket, or multiple strings are going inside the same bucket. So that's how it is working. That's the collision is happens. And using chaining we can avoid that, or we can just handle that using the chaining method. Now a simple note is that collision do not break the hash table. Yes, collision do not break the hash table, they allow, they just slow it down if too many happens. Obviously in this case, like here only 4 values are there. Let's say if multiple values are coming inside the same bucket, then it will just slow down the process, but it do not breaks the hash table. That's the important thing. And why this is because if we use the good hash functions, then in that case the collisions will not happen, or even if the collisions happen, then in that case they can be easily like we can easily avoid those collisions. So if the good hash functions are used, so good hash functions matter a lot to choose the good hash function. And bucket count matters, yes. And then load factor is monitored. Load factor is nothing but the whatever the number of elements are there or values are there, just number of those elements divided by the number of bucket count, whatever the value comes, that is the load factor. So it is simply that load factor, if the load factor is very high, then in that case the collisions will happen a lot. Okay, so C++ just in CPHP, the automatically it performs a rehashing. Like if the load factor is very high and the number of collisions are going to be very uh, like too many collisions are going to happen, then in that case the rehashing is done. Like either the whatever the number of buckets it has taken, it will just double those number of buckets, or it can redistribute the elements, or this also improves the performance just by rehashing. Okay, so rehashing happens automatically if any such things happens, that if load factor is going high and number of collisions are getting very large enough. In that case, this can be done, like double the number of buckets or redistribute the elements, improves the performance, whatever it can improve the performance, it can be done. Now, some of the basic hashing problems we have just seen, all the basic concepts about hashing, like why hashing is needed, what is the hashing, how the hash function is used, how the values are stored inside a particular index in the bucket indexes in the hash table, what is the difference between the map and the unordered map, and how we use the different techniques, like if we are having smaller values, or for the character based size, or for the larger values we use the unordered map, like the hashing. So now let's solve some of the basic hashing problems, so that we can get more understanding that how to how to use those in the problems. So now there can be the different patterns of like frequency hashing, as I've already talked about, that if we have to find the frequency of a particular element or number of elements, that how many times they present, or we can get a problem where we have to check for the existence hashing, like when we solve the sum problem. In that case we will have to get to a value for the complement value, that if it exists or not. So that is a kind of existence problem. Does exist, have we seen this before, like some of the likewise, like to some problem obviously. And these can be there in the frequency, like how many times the something appears, any number appears, find if we have to find the duplicates, if we have to find most and the least frequent value. And then we have to count the frequency of characters or numbers, like anagram problems. And index hashing can also be there, like in the same problem, like in the two sum, if we are getting the we have to get the indexes, that what are the indexes whose elements give the sum as this. So that can also be there, index hashing. So like storing the first index of an element, checking the two indexes to satisfy a condition, storing when a prefix sum uh, first occurred. So these are the problems. Now let's get into the problems first, and let's try to solve. First problem is count the frequency of each number in an array. That's I have already solved, but just for the understanding, let's get into this. We have to count the frequency of each number in an array. Where we can see that this is the array, and the maximum value here going till 4. So I will have to keep the frequency array of size 5, so that it can get the indexes from 0 to 4, and it can keep the counter for every for the frequency for every element. And at the end I will just I will just print those frequencies. So just get into the code. Okay, so this is the check the occurrence. And now this is the array I am given with. Now firstly I will have to create the frequency array. So I am using the frequency array frequency hashing because the values are smaller enough. So this is the frequency array, and in this frequency array, what will be the size is going to be 5. And those are initialized as of now, all the values to 0. Now what I will do, I will just perform a traverse. I will just loop on this entire array for int I equal to 0, I less than n, I plus plus. And now inside this, while traversing in the entire array, I will just increment the counter for every, I will just make sure to increment the counter for every value. So I will just get into the, for every element I will go into the frequency array, and I will say that in the frequency array, whatever the value of this is, that is nums of I. So if this nums of I is this 1, then just go at this 1 in the frequency array and increment its counter, that it is increment its frequency, that it is available in the array as of now for one time. Later when 2 will come, it will increment for 2, another 2 will come, it will increment the 2 for the frequency of 2, and then it will again increment for these all the values. And now I will just make a counter, sorry, I will just run a loop for the frequency array, int I equal to 0, I less than, what is the size of frequency array, as of now it is 5, and I plus plus. And now inside this I will just say that whatever the frequencies are greater than 0, just print those. So if the frequency of this I is greater than 0, then in that case just print that value. So if it is greater, then just print that I value. So this is a simple thing. So this is the frequency of I, like whatever the frequency of I is there, I will just print those values, that whatever the frequencies are greater than 0. And also I can print here that yes, this is the frequency count. Maybe I can take this value, that this is the value I, and print its frequency, the frequency of. Now let me just take the array, same array, 1 2 2 3 1 4. Size is 6, 1 2 2 1 4. Let me just run this. For this particular, now it will give the frequency count for every value. Like for any value will be coming, like 1 comes, frequency count for 1 will be 2. Let me just print this way, help, that it can print in the. Just printing like 1 is present 2 times, then 2 is present 2 times, 3 is present 1 time, and 4 is present 1 time. So this is the problem for the first problem, that is counting the frequency of each number in an array. So we have just taken every value and printed their frequencies. Now getting into this was the problem I have already discussed. That's why I have just written. Second problem is that how many times each character appears in the string. So now I am having this particular string, and in this I have to count that how many times each character appears in the string. Now here only lowercase letters are there, so I may use the frequency array of size like 26 only, because the lowercase characters are only there. But to be at the safer side, we don't know that what are the hidden test cases are there, what are the number of characters are present, either mixed or somewhat. So we can just use the frequency array of size 256 just to get the safe. So this is the string already we are given with, and now I have to find the how many times each character appears in a string. So I will just make a frequency array, same, the frequency array of size 256, and that whose indexes will be going from 0 to 255. And now these a based offsets will be there, like the values will be mapped. Or see, if I am using this particular size frequency array of size 256, so now we already know that from 0 to 255, these all are nothing but the ASCII codes of these characters. So we need not to convert that in the array based offsets like 0 to 1, sorry, a to 0, b to 1, like that. If we are using the 26 size array, then in that case we have to use that. But in case of 256 size, because these are the ASCII codes 0 to 255, so in that case we can directly use the values, because they are directly mapping with the indexes. So that is like the index to character mapping, or the character to index mapping, at the time of printing or also at the time of incrementing the frequencies. So let's just get into the second problem. This is the character frequency, and now I will be firstly making the frequency array. Again, this is the simpler one, so I am taking the frequency array hashing. I'm using the frequency array only, frequency hashing, or the character hashing, I can say. So this frequency, I have taken frequency array of 256 size, that is will be the indexes from 0 to 255. Now what I will do, I will just run a loop in order to traverse in this string. For int I equal to 0, I less than n, I plus plus, and while traversing, what I will do, I will just go at every character and increment its frequency. So take this frequency array, and in this frequency array, for every character as this s of I. So in this, for this s of I is the character, and for this s of I character, see, you can also do one thing, that this is the character, so you can also typecast it. So integer of this, so you can also typecast it and then increment its frequency, so that it can increment the frequency by going at the index, or maybe it can also be converted directly. And now after incrementing the frequency, like for every character you have done, for a you have counted the frequency at this, for and then for b, then for c, like that for every character. And now if you have to print that how many times each character appears, you can just do the similar thing as we have done in the previous problem, that int I equal to 0, I less than n, and sorry, not I less than n, because this is the frequency array that will be of size 256, and this I plus plus. And now inside this, if the frequency is greater, whatever the frequency is, if the frequency of this character, or this frequency of I, that is greater than 0, we have to print that one, because that is the number of times we want. So here you can just print this. Firstly, you can take this whatever the I is, that is the I is a, see now what is the, these 0 to 255, these are the basically ASCII codes. These are the ASCII codes of those characters. So if you are having I, that means it is a ASCII code of that particular character. So you will have to, if you have to print that character, you will have to convert, or you basically I can say you will have to typecast that uh, this ASCII code into that character. So we will just use the char data type and give this I inside it, so that that I ASCII code can be converted into the character. And I have taken, simply we have taken now this value for that character, and now how many times it is appearing, just take that frequency of that character, that is frequency of I, so that it can print. Now this is the already the string I have taken, and no any input we have to take here. Just run this code. So okay, so this is okay, this was the previous I have taken. Let's just take this. Will also give the result. Means it was giving the result for that previous input. Let me just write for handle. Let's run this. In this case, that then yes, it is giving the result that A is present for 3 times, B is present for 2 times, 1 is present for, C is present for 1 time, D is present for 1 time, E is present for 1 time, and F is present for 2 times. So that's how we have solved the problem. Let's also see the time complexity of this. So if I see the time complexity in the first problem, then because this loop is running for n, it means it is counting the frequency for all the elements inside the array. And yes, this is the for n times. And if we see in this loop is running for a particular fixed size of array, that is in this case of frequency of 5 size, and it can be based on whatever the maximum value is. So that can be done. Let me just get into the previous problem, because okay, so it's like we can, one thing is important that I have missed here, that whatever the frequency already I have explained, but yes, whatever the maximum value is inside the array, we have to take the frequency array of size that maximum plus 1. If the maximum value is 4 in this case, then it will be of 5 size. You will have to firstly find the maximum value on that array. In order to get that maximum value, you can just use the simple approach what we use to find the maximum element inside the array. So for this we will just run a loop for int I equal to 0, I less than n, I plus plus, and if we have found that this nums of I is greater than this max, okay, so we will then just update this max with that nums of I, that nums of I, and this is how we will get the maximum element. And what then, whatever the maximum element come, just take that maximum value plus 1, that max plus 1 will be the size of this frequency, and that we can use here as well, this max plus 1. So this is how. Now this max plus 1 can be anything. Just consider that whatever the range of values, or the maximum value is, let's say k, then it will be going till like 0 to k minus 1. Sorry, if the range is sorry, maximum value is k, then it will be going till k plus 1 maximum value. You can just approximately just take that k. So the time complexity will be like this big O of n plus k, like that. That will be the time complexity in this case. And yes, in this case the space complexity will be that uh, we are using this particular array itself, this frequency array, in order to keep those frequencies. So because it is of like range k, for the, just consider that the range is, the simple range is k. So in that case, in order to store these, the that will be big O of n, space complexity. Now again in this character frequency, same, because here the value is not we have to find for the maximum, we can just take it for the safer side. So the time complexity will be big O of n, and the space complexity will be constant, because so this is a size which we already know, and that is fixed, that will not be increasing. So that's why the space complexity is used as constant. Now that's problem also we have solved. Now let's come to the another problem, that is the problem 3. Problem 3, that is the check if the two strings are anagrams. Firstly, what is anagrams? Anagrams, we say two strings as anagrams if both the strings are containing the same characters, and also their frequency count is also same, means same number of characters, same characters and same number of characters. That we say as the anagrams. That's the simple example. Listen and silent. Here the characters are same in both the strings, and also the number of times that character is present, that is also same in both the strings S and T. So in order to check that both the strings are anagrams, we will have to use a simple approach. Like we already know that yes, if both the strings are anagrams, then firstly their size should be same, because if the size is not same, then we can obviously, it's logical, we can say that they are both are not anagrams. Because if they are anagrams, there are the same characters and same number of characters, so size must be same. So initially just to check for a early case, that if the size is not same, then we need not to check that they are anagrams or not, they are indeed not the anagrams. Firstly check the size, and if the size is same, then we will move ahead in order to check that thing. So firstly we know that these are having the same size. Now let's go ahead and check that how we can check that these are anagrams or not. So what we can do here is characters hashing is there, the characters are here. So in that case we need not to use any another technique or something, because these are the characters and they are having the fixed size, so we can just use the frequency array that is of size 256. Now in this we will just take that frequency array and increment the counter for the characters of the first string, and whenever we will be going to the next string, we will now then start to decrementing their frequencies. Now what is the intuition behind this? The intuition is this, that if we are firstly incrementing for the first string, then if it is an anagram, then later on whenever we are decrementing for the second string, for the frequencies, that must become equal to 0. So whatever the frequency count is incremented at the S string, that must be cancelled with the matching character inside that when the decrementing is done in the T string. So let's get into the code part and let's understand more about this. Firstly, let me take the frequency array in this. That is the frequency array of size 256 again. And that will be firstly initialized to zeros. All the values will be zeros. And now I will just start with the incrementing for the frequencies of the S string. So I will just run a loop for int I equal to 0. For int I equal to 0, I less than this n1 size for the S1 string, and I plus plus, sorry, S string, I plus plus. Now what I will do, I will just go inside the frequency array. Inside the frequency array, what I will say, see, this is my character. Because I know these are the characters which, because I'm using the frequency array size of 256 that I already explained. So the indexes will be the ASCII codes for the characters. So I will just take this S of I, that's going at that, or I can also just make it, I can also just use the typecasting in order to convert those. Otherwise maybe it can also be it will also work without. Just increment the count of the frequencies. Now again run a loop for int I equal to 0, I less than n2, now this time for t size, and I plus plus. Now this time what I will be doing, I will be going in the frequency array and of this t of I, and also I can take this integer typecasting, and in this what I will do, I will just decrement the counters. So let's suppose this is these are the strings. In this case every character will be in this, whatever the counter is there for every character. For S it is 1, for I it is 1. Now when this is taken, when it will go to L, it will decrement it, that already 1, it will be decremented and cancelled out. For I it will be decremented and cancelled out, and therefore when all of them are 0, if all of them are zeros in the frequency array, that means these both are anagrams. But if any of the value is not equal to 0, it means those are not the anagrams. Some of the characters are there which were more inside the previous string, or they are that means the different inside the both the strings. Just we have to run another loop and just go inside this frequency array till 256. Okay, I less than 0, I plus plus, and we just have to do one thing, that if any point of time we found that this frequency of I is not equal to 0, then in that case itself just return false, because all the values must be zeros. If any of the values not 0, it means it is not true. And if we just came out of it and we have not found any of the value as non-zero, then it is going to be true. That means those both are anagrams. Now I have just manipulated this particular example, and it should give that both are not anagrams. Just run this particular code, and it should give the output that this S and T are not anagrams. Okay, so it is giving that S and T are not anagrams. Now let's also see the time complexity of this code. So firstly, the space complexity is simple. That is the fixed array size is used. So the space complexity is going to be constant. For the time complexity, it is like big O of this till n1 plus big O of this n2, like that. So that is going to the time complexity. Now let's get into the another problem. The another problem is the find the first non-repeating character in a string. So first non-repeating character in a string means whatever the first character which is whose frequency is only one, and that should be the first character which is not available in the entire uh, string later. It is only present one time, and that's what we have to find the first non-repeating character, not the one of the non-repeating character, the first one which is inside the string. This is the input I have taken, and in this which is the first non-repeating character. C is the first non-repeating character, so I should return this C as the first non-repeating. Okay. Now I will explain more about this. So obviously this is again a string problem, so in this having the characters like this, so I will just write the code for this, and then we'll explain how it works. So simple intuition behind this is I will just take the frequency array as always, and that is of 256 size, and then I will just traverse in the entire array, so sorry, in this entire string, and then we'll keep the frequency counts of these characters in that frequency array, and then I will just traverse in this string again, and we'll see that which of the first character is there. I will not be checking the frequency array that whose frequency count is 1, so that will be the non-repeating character. No, there can be multiple characters in a string which are non-repeating, which are only coming once in the string, but I have to find the first one, so that I will get only when I will be traversing in the string again. So that whatever the first character comes, I will just check its frequency in the frequency array, and whose frequency count came as 1, I will be returning that this is the first non-repeating character inside the string. Let's get into the code part. So this is the frequency array. Again I have taken as of size 256, and again it is of the values initialized to 0. Now running this entire loop, I equal to 0, I less than n, and I plus plus, and every time go in this frequency array and increment the count of this. So s of I, and just increment the count, and after increment, okay, so in this I have just run a loop, and I'm just checking inside the string that what is the first character inside the string which is coming as 1. So if I found the frequency of that first character as 1 inside the string, sorry, inside the frequency array, I will just return that character. So here it is giving that first non-repeating character is C in this case. Okay, now let's get into the next problem. Also, let's see the time complexity of this. So again, the space complexity is going to be constant, and for the time complexity, it is just taking the frequencies of all, so that will be big O of n, and plus that will be for some, like it is we are checking for the string s. So again, for checking string s, if just to get that character whose frequency count is 1 inside the frequency array, we are running this as well. So the time complexity will be both adding of this big O of n plus that big O of some value. Okay. And now get into the another problem. This is the another problem, that is check if the array contains the duplicates. So if the array is containing the duplicates, that means here the 1 and 1, it is present 2 times. So in order to check if the duplicates are present or not, what we can do is here we only have to check for the duplicates. So we can use we can just use that the unordered set instead of the unordered map. Unordered set, why? Because we only have to check if any element is present again inside the set itself or not. So if the element is already present inside the set, then it means it is the duplicate, and we can just say that yes, or we can just return to a kind of that yes, the duplicates are present in this array. So let's just solve this problem here. So the check duplicate problem, and in this, firstly I will just uh, take the unordered set, and inside this the values will be of the integer type, and this is the set here. Now inside this, what I will do, I will just run a loop, for auto, and I will just take all the values from this nums array. And what I will do, I will just take every value and starts and just firstly I will check that if it presents in the if it is already present in the set or not. So that is writing the if condition, that if this I will find inside the set, that set dot find well, if it is already present, if it is already present, uh, I will check that if it is equal to set dot end or not. How is it working? See, if I found a particular value inside the set, then it will be returning a particular value which will not be equal to dot end, and that condition will be true. It means I will just return that true here, that yes, I have found the element, and that is the duplicated means. Or otherwise, if I have not found such thing, then I will also have to do one thing, that if the value is not present, then just insert it inside that set. So set dot insert, these are all the functions. These I have explained inside the STL video. Sorry. So this insert this particular well, and at the end just return true, sorry, return false, you have not found any. Just return false, that yes, the duplicates are not present. Let me just take the input here. What is the input? 1 2 3 1. So the size is 4 and the elements are 1 2 3 1. Now let me just run this code here. So for this particular input, for the size 4 and the elements as these, that it should give that the duplicates are present. What's the output it is giving? Is the duplicate present? So one is present 2 times. Now again, in this, the time complexity, if we see the space complexity, firstly the this time complexity, let's see. Firstly, the time complexity is for this particular loop, what we are doing, we are performing this find operation and this insert operation, which takes the constant, which takes the constant lookup, we can say, which takes the constant time. But as these are performed for all the n number of operations, so what happens is that they takes the on an average, that is big O of n operation, that is big O of n time, you can say. But let's talk about its worst case, what can happen. So obviously whenever the value is going to come, it is taking the hash value and then start and then keeping inside the hash table inside the bucket. But what if the values are such that all the values are going inside the same bucket? Then in that case, what will happen? Just see that if we are having a such case, if we are having such case that all the values are going inside the same bucket, then it will be a form of the kind of linked list inside every bucket. Internally they are using the linked list. So in that case, whatever this find operation is performed, the find operation will be performed, let's say the first element is inserted inside the same bucket, then it will be taking the constant time. Let me just write in this way, it will be taking the constant time big O of 1. Then another time, if the first element is going, then it will be another element is going, it will be taking big O of 2. Another time it will be taking big O of 3. Another time it will be taking big O of 4, if all elements are going inside the same bucket. And likewise, whatever the number of these are there, it will be going till n minus 1, because for the last value which is going, it will be taking n minus 1. In this way, if we see the formula, the formula will be like n into n minus 1 divided by 2, that is a kind of big O of n square. So that's what I have to say, that in the worst case, what will happen is that as of now, these all are the elements which are same. Sorry, we are if they are going inside the different buckets, in that case the find operation, insert operation, their lookup operations, they are constant, and for every element. So for n elements, that will be big O of n at an average case. But in the worst case, if all the elements are going inside the same bucket, then in that case the find operation which will be taking for every element, it will take a like a kind of big O of n operation. Such n operations has to be performed, that will lead to big O of n square time complex. So the time complexity is big O of n square in the worst case, and in the average case, that will be big O of n. Okay. Now again, the another set is used, so because of which the time complexity will space complexity will be big O of n. Problem is also solved. Now let's get into the another problem. And the given an array, return all the elements that appear more than once. That's very simple. We can simply do, we can take the because we have to return all the elements that appear more than once, so we will have to keep the frequency count of those elements. So for that, we will be using the unordered map, and in that, what we will do, we will just keep the frequency count of every element in the unordered map, in the hash table, just map with those frequencies, and just traverse inside the unordered map, and look for whatever the frequencies are greater than 1. Just return those. Okay, so just uh, return all those elements, or we can just return those in the form of vector or something like that. So let's get into this problem. Elements appearing more than once. I will be returning that in the form of vector. So I will be just taking the vector for returning. Let's say the vector int m, and in this I will be storing all those elements. Now I will be firstly getting into the this running a loop for auto well and for all these nums, and I will be having I will be using the unordered map. So unordered map, and in this I will be keeping the values and their frequencies, and this by the name mpp. Now I will just go inside the map for every value, and for this value I will just implement the counter mpp of value plus plus. Now at the end I am having in the unordered map all the values with their frequencies. Now I will again run a loop, this auto, let's say val itself. I can see the pair pp, and now inside this I will check that if the pair dot second parameter, okay, because that is the second value, the key value mapping, so that is the second value, pair dot second. If it is greater than 1, then just take the stamp and push that value, push back function in the vector, just push that what pair dot first, push it inside this, and at the end just return the stamp. That's what you have to do here. And now what is the input? 4327, size is 8, 4327 and 8231, 8231. Let me just run this code here. What the output is going to give a number of elements will be present more than once. So result is 2 3. 2 is present for 2 times, 3 is present for 2 times. That's what the answer we need. Now let's get into the another problem, that is problem number 7, and in this there can be two categories, sorry, three categories. If you have to just get the two sum for the checking the two sum, if a target given to us, that is k, and the two numbers we have to find that if they sum to k or not. So that can be like if we have to return true or false. The true or false is just implicitly done when we find the pairs or we return the indices. And also the another category can be just return the pairs, which gives the two, which gives this particular target, or return the indices where those values are present. So that can be the case. So let's just get into the code of this. This is as simple. In this what we have to do is we just have to check for the complete for the like complemented value, that if it is present in the set or not. So in this we will be using the unordered set. This is the unordered set, and in this values will be of type integer. So this is the set I've taken. Now what I will do, I will just run a loop well auto well this inside the nums array. Now what I will do, I will just firstly what I will do for this particular value, I will just take the need variable, or variable by the name need. Why? Because I have taken the value, let's say what are the values, 2 7 11 15. The size for this is 4, 2 7 11 15, and now what is the target? 9 is the target. Okay, firstly let's say 2 came. Now what I will do, I will take my target and take the this complement of this. So 9 minus 2 will be 7. Now I will be finding for 7 inside the set. So for that I am taking the need variable. So this target, whatever the target is there, minus this value. So that I have taken inside my need variable. And now what I will be doing, I will just put a condition that if this set, I will just find in the set, if this set is having this need value, okay, that is written something like this, set dot end. And if that value, if it is found, then what will happen, that if it is found, then something different will be coming from set dot end. So in that case, this condition will be not equal, so condition will be true. In that case we will just return what, we will just return the indexes. So I'm sorry, not the indexes, the elements. So what will be the elements? One element will be the, or one value will be that need. And another value will be that already the value which is there, which I have been checking for. That will be the case in this. Otherwise, if I have not found, like I have checked just all, or let's say, see, in this case I'm just considering that it will give. So if I am not getting, then I will just return 0 as this. Okay, because I have to return the vector format. If the values are there, then I will just return this need comma well. If this is not found, then just take this set and insert this value. That's the we have to do on this case. It should give 2 and 7 are the values which sums up to 9. Now if we have to also get the index, then in that case we can just run this loop like this way, and I equal to 0, I less than n, and this I plus plus. Now if I am getting the need, so for this nums of I will be here, and if I have found that, then in that case I will be just okay. So in that case we will have to use the unordered map. In that case you will have to use the unordered map, because we have to keep the track of indexes. Unordered map, unordered map, and in this the value will be there and its corresponding index will be there, and its name is mpp. Okay. Now just get into this, find in this map. Okay, you found the value. Yes, if you found this need, just come here. What you will do, you will just return this index, whatever the index is there corresponding to that need. Okay, so already if this 2 is there, so already it is not present, so I will just insert that 2. Okay, I will just insert that. Now one thing we have to do there is that mpp of that particular value which we have taken, we'll have to give it the index. Sorry, not value, that will be nums of, I. Just insert that. Otherwise if you have just not found, then just insert that, and next time when 7 will be coming, 9 minus 2 will be 7, 9 minus 7 will be 2, so that 2 will be finding, so 2 will be found inside this particular map, and which will be giving as yes, I have found, so condition will be true, and it will return map of need, because map of that particular 2, so map of 2, whatever the index is already present inside the map, and comma this particular index for which, sorry, for this particular index for which I am checking, it will give me that result. If I run this, be giving the indexes, will be giving the indexes. Place of 2 comma 7 is going to give the indexes. So I will have to the size equal to names dot, just run. So in place of 2 comma 7, it is giving the indexes what, 2 and 7, 0 comma 1, 0 1 are the values which sums up to 9. These are the indexes. Now again, if we see the time complexity, firstly the space complexity, again ordered map, unordered map is used, so space complexity is going to be big O of n, and for the time complexity, the it will be big O of n for the average case. Okay, and again we are placing these values. Okay, so can go up to big O of n square in the worst case. That's what about this problem.